All right, let's take a look at a couple important aspects of functions. So the first one we want to start off with is what's called domain and range. So the domain is simply all the x values that there are for a given function, and the range is all the y values that there are for a given function. And we can usually get these by looking at the graph. So if we look here at this line, we want to know what x values are there that correspond to a point on the line. All right, so what happens here is we're looking for all the x values that correspond to a point on the line. So if you pick any x value you want, how about 2? Okay, so we go to x equals 2, and we go up and say, yep, here's the point with an x value of 2. And we can do that for any number on this x-axis. So you just kind of look at the x-axis and see if there's any parts where above or below that part of the x-axis, your graph is missing. It's not there. If not, those will not be in the domain. Otherwise, they're in the domain, right? So here we can see that it would be all real numbers because any points along our x-axis, even if we zoom out, there's going to be a point on the line that has that x value. Okay. Now for the y value, you look at the y-axis. So you're looking right here at the y-axis and saying what points correspond right here? Well, any one you pick. What about 5? Well, here's the point that has a y value of 5. What about 1? Here's the point that has a y value of 1. So in this case, the range, the y values would be all real numbers, would be negative infinity to infinity as well. Now we usually write that in interval notation. And that would be written like this. The parentheses mean everything in between, but not including those endpoints. Positive infinity means you're going down this part of the axis. Negative infinity means you're going down this part of the axis. And anywhere on that axis, we can find the value. So this would be the domain for our function. And the range would actually be the same thing for this line. Now, what if we changed it up to a different graph? Well, in this case, the domain is still negative infinity to infinity because any x value you pick, say here, oh, there's the point that has that x value as a point. But what about the y values? What about the output? What about the range? Well, in this case, there's nothing down here in the negative portion of the graph. So there's no negative values in our range. So in this case, we would say that the range is 0 to infinity. That's how we would write that. It's all the values from 0 to infinity. And in fact, in this case, we would put a square bracket to include that 0. If you use a square bracket on the end, that means include that value. If you put a parentheses, that means it's everything right up to that value. Okay, right up to there. So that would be the domain and range for this problem. And we can see that because when we're looking at the y-axis, well, if I pick this value, yeah, there's points that have that y value of 5. But down here at, say, -2, there's no points on our graph that have a y value of -2. So we would exclude those. Okay. And we have a tool for determining quickly if something is a function or not. So if we take it's called the vertical line test. If we take a vertical line and you just pass it over your function, if it only ever hits your graph once at a time, then you have a function. Okay, so an example of something that would not be a function would be a circle. Notice how if I pass a vertical line over this circle, I hit it at 2 points at once. That means that this thing is not a function. Okay. Because right here, these are all the places where it violates being a function. So that's our vertical line test. Okay. Now, how do you go about graphing something that you're not familiar with, but we want to take a look at it and see if it's a function? So let's just take the function y equals x squared, and let's see if we can graph that thing. We've already seen what the graph of it looks like, but let's just see if we can come up with it on our own where the graphing utility is not doing it for us. Now, with lines, we only had to graph 2 points. Really good idea to graph 3 points. When you get into more complicated functions, you're generally going to have to graph more points. So you just kind of have to keep graphing points until you see what the graph is supposed to look like, and then you can fill things in. So you just start picking some x values, and then you find the corresponding y value that goes with that point, and you just keep plotting them until you think you get the hang of it. So let's see. Let's take like 2. And we know that our function is this one up here, which says the y value is equal to the x value squared. So if I square this x value, I now get 4. Oh, and there's a point for us. Okay, what about 1? Well, if I square 1, I get 1. Okay, what about 0? Well, squaring 0 gives me 0. All right, what about negative 2? What if I square negative 2? I get 4. If I square negative 3, I get 9. Now notice we have a little bit of an issue here in that 9 isn't on our graph. So we can either adjust the graph and take a look at it like that, or sometimes points just aren't going to be on your graph and you have to hunt around for some more points that are going to make sense for you. But we can start to see now, if we keep plotting points here, how it's basically giving us this shape again. You know, we might have to plot some more points. But that's the idea of how you plot graphs that you're not familiar with. You just start plotting points until you see what the thing looks like.